Hi, good day to all listeners. Today I'm streaming outside of my classroom from Diesel High School in Saldanha Bay. My name is Mr. Kok. I'm a maths teacher at Diesel High School, and I am today having my class 11E as my participants, and we are going to do some revision on the September paper that we wrote, and we are specifically going to look at geometry. So feel free to post any questions in the live chat if you are watching this lesson. And this lesson will also be made available on my YouTube channel. You can just search my name, Ronald Kok, and you will can then obviously subscribe and hit the notification button so that you can get regular updates every time that I post videos. So, in today's lesson, we will be looking at one of the most important theorems in geometry, and this is the theorem the angle at the center is twice the angle circumference, and we need to prove that the angle at the center is twice the angle at the circumference. Now, this is a very important theorem that a lot of things are based on. Remember, all things about a circle evolves around a point. So the concept of the angle at the center, which evolves around a point, brings about the importance of this theorem. So let's have a look at what we have and how we can solve this problem. Right, so we have the circle. The diagram is given to us, okay, and our diagram is given to us as P, R, and Q at my midpoint, and then from the midpoint to the circumference, I know that's a radius. To that midpoint circumference radius, so I can then obviously logic tells me that these two radii are equal radii, and then I connect that point, and then at the center the angle is O. So now I know for a fact that that's a radii and that is also a radii. Okay. And what I can do in geometry, and I'm allowed to do that, is to construct or make constructions. Okay. So the first thing for this question, before you try to solve or show what the solution is, you absolutely have to make the construction. If you don't make the construction, you don't get marks. Because then logic comes from how do you know these things? There's no construction in there, so you can't use the concept of the interior angles of a triangle because you haven't created the triangles together. You get what I'm saying, learners? Okay? So we know that we need to make the construction from P to O, and now we have created the two triangles. Are you with me, learners? Alright? So please just keep that in mind, because if you don't do that, you cannot say that POQ is the interior angles of POQ is 100 degrees because you haven't made the construction. So I can do that as well, and I can say, I can make a statement. I can say construct PO. You can make that statement, you're going to get a mark for that. And then I can also say that PO is equal to OR is equal to OQ. And can I make statements in geometry without giving reasons? No. You can't do that. You have to give a, what will my reason be here? Equal? Equal? Radian. Okay. So in geometry, just tell yourself this. So you know, as a point of departure, as a form of pre-knowledge, is that I can't make statements if I cannot supply a reason. So don't do that in the exams. If you write something down but you don't give reasons, don't do that, because that's obviously incorrect. So now that I know that, maths also allows me to make things easier for myself by replacing it with some placeholders. Okay, so in this instance, we now know that P, when I constructed PO, I've divided angle P into how many angles? In two angles. So I have an angle 1 then an angle 2 there. Okay, right? So now that I have that, I now know that that is an angle. So from this I can now deduce that angle R is equal to angle P1. Okay, so I can write that down, but can I write it down without the reason? So, but we are going to make that statement now. We're going to say that P1 is equal to angle P R O. That's true, but we need to give a reason. You see, now let's go back to our pre-knowledge. You always go back to pre-knowledge. Going back to pre-knowledge, if I remove POR, this triangle, you see it takes you back to the basics now. Follow what I'm saying? What type of triangle is this? Look at this, look at this. Look here, look here, look here. What type of triangle is that? Ask me the vraag if you are correct. Try again. You use your devices. Use your technology. Okay. What do we have here? Anyone? Anyone? You see now this is where it becomes very important. If your pre-knowledge is non-existent, you are going to be stuck like this. Look, your learners, you are not going to be able to supply a reason. Right? Okay? Let's say I saw this triangle, but you need to be convinced of yourself. You say this with conviction. Right? Or you can just say PO is equal to OR. You don't have to say isosceles triangle. You can just say the reason, and you can do that, and you can say PO is equal to OR equal radii. That's also a reason. Happy with that, learners? So now that we know that P1 is equal to P or O, and the reason there is equal radii, or we can say PO is equal to OR, or you can give the other reason as well. We can say the same for P2. Angle P2 is equal to angle PQO for the same reason. Happy with that, learners? So now to make my life easier, I'm going to calculate this mathematically to show that the angle at the center is twice the angle at the circumference. So let's do that mathematically. So let's say, let P1 be X. If P1 is X, angle PRO is also X. Can we say that? Because they are the same. If angle P2 is equal to angle POQO, let's make that Y. Because then they both are the same. Are we happy with that, learners? Alright. So when I brought in PO, I also changed the dynamics of angle O. So angle O is now divided into 1, 2, 3 angles. Do you agree with me on that? Angle O has been divided into 3 angles. So I can say here angle O1 plus angle O2 plus angle O3 is equal to 360 degrees. Can I make a statement out the reason? What's the reason? Angles. I'm okay with that. There's a lot of symbols that you can use in geometry that's acceptable. Okay, a lot of symbols. You don't have to write out the word parallel. You can just make a P and do that. You can just make that. There's a lot of things. You can also say interior angles of a triangle. So you can use the symbols. It's acceptable. Okay. Right. So now I know that is. Now I can continue, and now I'm going to work in my triangles because I would like to now work towards the angle at the center to prove that it's twice the angle at the circumference. So I'm going to focus on my triangles now. Happy with that, Ernst? Happy with that? Yes or no? Yes. Good. So I'm going to look at if this is x and that is x, how many x's do I have in this triangle there? I have 2 x's. So I'm going to say 2x. Are we with me here? Plus angle O3 is equal to 180 degrees. Can I make statements without reasons? Reason? You can say interior angles of a triangle. Close the bracket. Are we happy with that, guys? Alright. And I can say the same for the other triangle as well because they are equal radii. So I can say 2y plus angle O2. Angle O2 is equal to 180 degrees. Reason being? Interior angles. Right? Same story there. Alright, learners. So now, look at this. I am now working towards this for simplification. And I'm going to make O3 and O2 the subject of the formula. So let's look at how we make that the subject of the formula. To make O3 the subject of the formula, I must get rid of 2x. So I subtract on both sides. Do you agree with me? Yes or no? Yes. Good. So it's angle O3 is equal to 180 degrees minus 2x. And I can say the same for this one here. Angle O2 is equal to 180 degrees minus 2y. Are we happy with that, learners? Yes. Look at this now. Now it becomes nice. Look at. Now I know what O3 is. I also know what O2 is. And now O1 is the angle at the center. O1 is the angle at the center, which should be twice the angle at the circumference. See, I've set up an algebraic equation for myself. I'm doing it algebraically, which is the smartest way of doing it because you're showing much depth as well. Because with other mathematics, with other geometrical reasons, it becomes very abstract. But with this, you show some depth in understanding. You follow what I'm saying? Because you're bringing a lot of elements together to make sense out of it. Do you follow what I'm saying, Lance? Good. Okay, so let's continue on with this. So now that I have that part there, I'm going to substitute this into that equation. Because I know what O3 is, I also know what O2 is. So now I'm going to say angle O1 plus 180 degrees minus 2x plus 180 degrees minus 2y is equal to 360 degrees. Look at this, because this is the value of O2 and this is the value of O3. Happy with that, learners? I may have slightly said O2 and O3 and I should have said O, but it's not going to make a big difference. So now, let's simplify. O1 is 180 plus 180, that's plus 360 degrees. Do you agree with me? Yes, sir. Minus 2x minus 2y is equal to 360 degrees. Are you happy with that, learners? Now I know if I'm going to simplify this algebraically, this is going to cancel out. Happy with that, learners? So now I'm left with angle O1 minus 2x minus 2y equal to 0. Alright? I'm going to take angle O1. Keep in mind, look here, angle O1 is the angle at the center. So I leave it as it is. So angle O1 is equal to 2x plus 2y. Are we happy with that, learners? And then I'm taking out a common factor here to make that statement true. 2 times x plus y, and my answer is so. But let's understand what's going on here. Alright, now I bring my angle to the center. The angle at the center is angle O1. The angle at the circumference, this was x and that was y. Do you agree with me? Yes. X plus y gives me angle P. So I can also say here that O1 is equal to twice P. Meaning that the angle at the center is twice the angle at the circumference. Any questions at this point? Any questions at this point? Is it clear? Right, so thank you very much. And to our viewers as well, please subscribe to the channel and click the notification bell to get recent updates of lessons that will be posted and be the first ones to get access to those lessons. Thank you very much for your time, and to my learners, thank you very much for your participation. Okay.
Let's try.
That's fine.